NASA's Mach 9.6 X-43A hypersonic scramjet is still one of the greatest engineering marvels ever built. 2 decades later, its data, design, and daring flight remain the cornerstone of hypersonic research across the world. Imagine an aircraft smaller than a car, flying at nearly 7,000 miles per hour, faster than any jet before or since, and doing it without a drop of rocket oxidizer. This isn't sci-fi. This was 2004, and NASA made it happen. Just a couple of decades ago, aviation had a clear rulebook. If you wanted to fly fast within Earth's atmosphere, you used a jet engine. And the undisputed king of that world was the SR-71 Blackbird, built by Lockheed Martin's legendary Skunk Works team. That bird could touch Mach 3, faster than a rifle bullet. But if you wanted to go faster than that, way faster, you'd have to leave jet engines behind. You'd need a rocket, which meant hauling your own oxygen, burning fuel like crazy, and behaving more like a spaceship than a plane. That was before NASA changed the rules entirely with the X-43A, a sleek, unpiloted test vehicle just 12 feet long that shattered every known speed record. In 2004, it flew at Mach 9.6, roughly 10 times the speed of sound. It was the product of a $230 million experimental initiative called HyperX, designed to prove one radical idea, that a scramjet, a supersonic combustion ramjet, could actually function outside a lab. Before that, hypersonic flight was something scientists could only imagine through computer simulations and wind tunnel tests. But the X-43A would take those numbers and turn them into history. Now here's how it all worked. The X-43A couldn't take off on its own. Instead, NASA used a B-52B bomber, a flying giant from the Cold War, to lift the tiny scramjet testbed up to around 40,000 feet. From there, the X-43A was dropped, attached to the nose of a modified Pegasus rocket. The rocket ignited, blasting the craft higher and faster, pushing it toward test altitude. But it wasn't all smooth flying. The first attempt back in 2001 ended in failure when the booster malfunctioned, forcing the team to go back to the drawing board for nearly 2 years. Yet, as with most pioneering technologies, every setback was a setup for a comeback. In March 2004, NASA tried again, and this time it worked. The craft reached an astonishing Mach 6.8, already rewriting aviation textbooks. Then came November 16, 2004, when a second X-43A prototype roared through the upper atmosphere at Mach 9.6, or nearly 7,000 miles per hour, flying around 110,000 feet above Earth. The engine burned for just 10 seconds, but that short burn proved everything. For the first time, a scramjet had successfully propelled a craft to hypersonic speeds using air from the atmosphere, not onboard oxygen. Now let's unpack the brilliance behind that. A scramjet, short for supersonic combustion ramjet, is one of the most exotic propulsion systems ever conceived. It has no moving parts, no fans, no turbines. Instead, it uses the craft's own forward speed to compress incoming air. The airflow remains supersonic even as fuel is injected and ignited. Think about that. A flame burning in a hurricane of air moving faster than sound. Maintaining stable combustion under those conditions is like trying to light a match in a tornado. This is why scramjets can't work at low speeds. They need an initial rocket boost just to reach the velocity where the airflow compresses itself enough to sustain combustion. But once it lights, the payoff is massive. Because the scramjet breathes oxygen from the atmosphere, it doesn't need to carry heavy oxidizers like a rocket does. That means it can be lighter, more efficient, or carry a greater payload. Of course, the HyperX program was never intended to build an operational aircraft. From day one, it was a pure research mission. 3 flights, data collection, and done. And when those 2 successful flights concluded in 2004, NASA had achieved exactly what it set out to do. It had proven that hypersonic air-breathing flight wasn't just possible, it was repeatable. But the legacy of the X-43A didn't end there. After HyperX wrapped up, the U.S. Air Force took the baton, determined to carry the technology forward. The result? The Boeing X-51 WaveRider. This next-generation scramjet platform directly built on NASA's data and design philosophy. And by 2013, it achieved something unthinkable just a decade earlier: a 210-second sustained scramjet-powered flight. That's more than 3 minutes of stable hypersonic propulsion, an eternity in this world. And it was all thanks to the trail NASA blazed with the X-43A. But maybe the most important legacy isn't a single aircraft. It's the knowledge. The X-43A's data became the blueprint for every American hypersonic program that followed. It taught engineers that at hypersonic speeds, the entire aircraft and engine must be designed as a single integrated unit, one body, one system. It also gave scientists the data they needed to master the brutal thermal and aerodynamic forces that occur at near-orbital velocities. Even today, engineers designing modern hypersonic systems, whether for reconnaissance, strike, or space access, still refer back to that 20-year-old flight data. It's the answer key, the gold standard that validates computer simulations and flight models. And here's what that means for the future. The dream of flying a vehicle directly from a runway into orbit, no booster stages, no rocket stacks, might not be fantasy anymore. The X-43A showed the world that air-breathing hypersonic propulsion works, and that's the foundation for the next era of aerospace: space planes, reusable launch systems, and hypersonic strike platforms. NASA's tiny 12-foot scramjet experiment may have burned for just 10 seconds, but those 10 seconds changed the trajectory of aerospace history. From the X-43A to the X-51 and now to classified Air Force hypersonic programs, its legacy continues to shape the race for the skies. Because in the end, the X-43A didn't just break speed records, it broke the limits of what we thought was possible. And that's why even today, NASA's Mach 9.6 X-43A hypersonic scramjet remains an engineering marvel.